Hi, this is Justin, and I'm going to talk about the transfer layer that's part of the Decilium protocol in this video. This is a video that's intended for somebody who's interested in technology or has some familiarity with technology, but you don't necessarily have to have a technical background to understand the content. As I've mentioned in other videos, the general realization and the general inspiration of the Decilium protocol is that users bring their own devices to your application, so you should use their devices for to operate your application. So for things like user sign-in, data storage, and other features that are inherent to your application, users can help each other. You don't have to be in between them or front the cost of responsibility for services that can run natively on people's devices. So let's talk a little bit about what that means in the second layer of the protocol, and we'll go over an example of the transfer protocol. The transfer protocol sits on top of the proof layer, which you may have just heard about, and it handles things like file uploads, website uploads, validation, hosting, so acting like a web server through WebRTC or HTTP, version control of documents, like being able to tell which version of a document has existed or does exist, user registration, user management, propagation of data across nodes, and registration on the network. So if you're a new node or if you're running your own private network, you have to run some code so that the different nodes or computers in the network can discover each other and begin performing the other operations. So that is the transfer protocol, just as a reminder right here. And we're just going to go through a very simple, very, very accessible example of uploading a website. Websites aren't the only kind of media supported, videos, files, any file type really can be can be an example. Let's talk about the status quo first, just because it's very stark. So the status quo sees developers creating an application. So lower right in the corner here, we can imagine a developer that may or may not be a direct employee of the corporation completes an application. And they're going to upload that to some corporate accounts, like an AWS account or a Google Cloud account, and they're going to embed that in a web server. And then that app there lives on the server, ready for people to access it. Now, there's probably some sort of DNS server. Every website has a DNS entry with a major host like GoDaddy, and that would point to the web server as well. And what happens is that someone on the internet, somewhere in the world, types in your web address, and boom, they get your new version of your web app. So that's how things work today. There are obvious problems with this. Like if many users collude together, they can try to attack your website and they need to throw up things like Cloudflare or DDoS, and then that's another corporate service to manage. You might also, because you store applications here, you might have application data. You may have to satisfy certain privacy audits, government audits. You might have to worry about hackers trying to attack these resources. So in general, even after you update the website, you might have to deal with like hosting and operations concerns around all of these above issues. So let's just look at the same example again, but from the perspective of Decilium. Things work a little bit differently. So again, it's the same. So you have a developer and they create an application. But where things change pretty quickly, because during the upload procedure, you don't actually upload to any corporate controlled computers. You may if you'd like, obviously, but the software allows you to actually upload the app to one person on the network. So you send them your application and some version info and your keys, your signed permission. You don't actually send your keys. You send your signed message or your signed app deployment. And that app actually through the propagator gets spread around the network. And now you have right away a situation where you have a reasonable amount of redundancy. So for free, because there are multiple users hosting the app, you have many users replicating the app, which means you have some fault tolerance. So how does this work though when someone wants to visit the website? And again, things look similar but a little bit different. So as always, somebody typing in company.com hits your DNS server. But where things sort of change is that the DNS server actually redirects you to a well-known user. So it might be a user that has like a static IP address, or it might be a user who's really reliable or online. And there's usually dozens of such users for well-known applications. There are people who leave their app running. It's usually about between 5 and 25% of the population, depending on the kind of app. So like habit tracking software or software that like runs a clock might have very high numbers of, a game might have lower values, especially if people play for an hour a day. etc. But they'll be redirected to one of the people that's online who has the latest version of the app. That user will just actually serve a version of the website, which is cross-referenced against somebody else's response for security reasons. And then what we have is a situation where, there's no hosting going on. So as you notice, all that the company had to do was resolve the DNS. So you run the DNS responder from Decilium, and it actually just forwards you to the relevant computer on the network, and you benefit from cloud hosting. Now, in terms of hacking and compliance, as you notice, your users are running the application code. So because they're running their own software, they don't have to meet as stringent, the software doesn't have to be as stringent in terms of privacy guidelines. People are electing to run and store their own data and operate their own servers. There's a lot of free DDoS resilience, meaning it's very hard to deny this service. Even if you can imagine a case even with 1,000 users, it's effectively impossible to disrupt this service network. The only real attack vector is the DNS server itself, and that is very easy to thwart or to protect against. So other than websites, this sort of upload and propagation technology, the transfer technology is used for chats, event registrations, image hosting, contact transfers. So on your cell phone, sometimes you have contact cards, email servers, SIM card registration, payment processing, identity verification. All sorts of workflows work on the Decilium protocol. If it can be boiled down into a file type and the fact that it needs to spread through the network and be run within a virtual machine, then it's compatible. That's basically it. That's the overview of the transfer protocol, and thanks for watching.